So in this video now, we're adding to our derivative rules. So we've only talked about power rule prior to this lesson. Now we're going to add to it constant. We've actually already talked about constant multiple when we were doing our power. So again, I'll show you that, and sum and difference. So when we're taking the derivative of a constant, just a good old number, that will always be 0. So basically remember, right, derivative is taking slope. So if you just had the graph of a number, like let's say y is equal to 2. If I were to graph and find the slope, well, the slope of, so this graph is just a flat line. Well, what is always the slope of a flat line? 0. Even if you had like y is equal to, negative 248. Again, it is a flat line, so the slope is 0. Even if when we get to later down the road, y is equal to pi, right? Or y is equal to e to the third. They are irrational numbers, but they're still numbers. So if I were to graph these, they still create a straight line with a slope of 0. So whenever we're taking the derivative of a constant, due to that just being a flat horizontal line, the slope of 0, the derivative is 0. Now, we already talked about the constant multiple. So just to show you guys what this means, again, we're taking some number, c, all right, and multiplying it by a function u. So what this means is we just need to take the derivative and multiply that by c. And so we actually already did this. Like, let's say, for example, I want to find the derivative of 3x squared. So that means we have 3 is our c. This is 3 times, then find the derivative of the function, which is x squared. Well, the derivative is 2x, right? Because we would take down our exponent and subtract 1, then multiply. So our derivative would be 6x. So we've already done this with our power rule lesson, just now putting the rule with it. So constant multiple. Then here, the sum and difference. So the sum and difference just means, again, if I have u as a function, so like the x squared, and v is another function, and we're finding the derivative. If we are adding or subtracting them, we are literally just taking the derivative of these two functions and adding or subtracting them. And that's all that means here for the sum and difference. So like, for example, sorry about that, in the first one, we've got, oh, wait. Let me go back here. Sorry about that, guys. There we go, I fixed it. Okay, so let's say for our first example here, we are calculating our derivative. Now, notice we have multiple terms that are being added or subtracted. So we need to, according to that sum difference rule, we're going to find the derivative of each individual function. So like this is a u, this is a v, and we'll call that w, right? So we're going to find the derivative of each of our 3 terms here and subtract, add them together. Keep that here. So what is the derivative of 2x to the third? Well, again, just like last time, we're going to bring down our coefficient. So this is 2 times 3x squared, which is 6x squared. All right. So we've talked about that in the previous, but again, a constant multiple. Then we're going to go to the next. So that's minus 4x. Well, what is the derivative of 4x? Well, this is then just going to be minus 4 because we have 4x here with an exponent of 1, then bring down, multiply. 4 times 1 is 4 and minus 1, well, that's just x is, now it's x to the 0. Well, anything to the 0 power is 1. So that's why here you're just left with 4. So ultimately, you're just taking that coefficient. Then here our last is, oh, notice it's just a constant. And what is always the derivative of a constant? 0. So this is our derivative of our function. So then let's do the next. Notice how we're subtracting two different functions. So we're going to find the derivative. Here we go. This is 5 times the derivative of x to the negative 2 is negative 2x subtract 1, negative 3. So this is negative 10 times x to the negative 3. Then, of course, we'll rewrite that. Then minus 2 times, here, let me erase that here. 2 times the derivative of x to the 4th is 4x to the 3rd. So now this is 8x to the 3rd. So now I'll rewrite this so we don't have a negative exponent. So our final derivative of our function is negative 10 over x to the 3rd, because remember, right, negative exponent minus 8x cubed. So then our last one here. And notice how we're adding two different terms together. So we're going to find the derivative. So here we've got for the first, that is 3 times 2x, right? Our derivative of x squared is 2x. Then I'll keep going. Plus 1/4 times the derivative of 8 x to the 8th is 8x to the 7th. So now here we'll go through and simplify. So this is 6x, so 3 times 2x is 6x, plus 1/4 times 8 is 2x to the 7th. This is our derivative. So go ahead and pause the video and try the U-tries on your own. Oh, here, let me fix this one though real quick. I realize it's cut off just in case. There we go. Go ahead now and try these U-tries on your own. And here we go. So for the first one, you should have gotten the derivative of the first term is 24x squared from 3 times 8 and subtract 1 plus just x, because 1/2 times 2, when you bring down your exponent, is just 1. And then you're down to exponent of 1. And that is your derivative, because the derivative of a constant is 0. So then here, your derivative of this function was 12x to the 3rd from 4 times 3 here, subtract 1, plus 10x minus 18. That is your derivative of your second function. So then here, the third one, a little tricky with your signs here, so you got to pay attention. So this is 28x to the 6th plus 27x to the negative 4, because that is negative 3 times negative 9. So that's how you get the positive 27 and then subtracting 1. Then rewrite this as 28x to the 6th plus 27 over x to the 4th. That is your derivative of this function. So now here, in our next examples, just adding a little bit more to it. Here we've got, let me move this over. There we go. So here, again, taking the derivative of each term. So what is the derivative of 2x squared? 4x, right? 2 times 2 is 4, subtract 1. Now notice we'll need to rewrite. So this is minus 5 times x to the, here, you know what, actually, let me rewrite on the side here. So sorry about that. So 5 times x to the negative 1. So then the derivative is negative 5. Oh, so notice the two negatives are going to make a positive, because this was a negative, sorry about that, 5x to the negative 1. So positive 5x to the negative 2. because again, subtracting 1 from your exponent, there's -2. Then the derivative of a constant is just 0. So to rewrite this, our derivative of our function is 4x plus 5 over x squared. So then here, let's rewrite 8 times x, radical x is 8 times x to the 1/2. Let's also rewrite here, because this is technically a negative 1/4 x to the 9th. So that's negative 1/4 here times x to the 9th. So here the derivative of our first function. So what do we end up with here now after multiplying by 8? So 4, then x to the, what is our new exponent now for x after subtracting 1? Negative 1/2. Then here, when you multiply, using your constant multiple rule, what's your new coefficient now for the derivative? Negative 9/4. Then x to the 8th. Then what's our derivative of a constant? 0. So here to rewrite, our derivative of our function is 4 over radical x, so x to the 1/2, and minus, we can leave it as 9/4 or 9x to the 8th over 4. So then our last one, again, let's rewrite. So rewrite your function. So this is 6 times x to the 2/3. And let's also rewrite our other function here. So this is 3 times x to the -3. So now let's get our derivatives. So what is going to be our new coefficient now for our x here with our derivative? 4. 6 times 2/3 is 4. Then x to the, what is the new exponent now? Negative 1/3 when you subtract 1. Then now here, what is our new coefficient for our derivative? -9, right? From 3 times -3. And what is our new exponent for x? -4. Subtract 1. So now let's rewrite for our derivative. So our derivative is 4 over the cubed root of x, because that's x to the -1/3 or x to the 1/3, minus, so 9 over x to the 4th, because again, x to the -4, so make sure to write that reciprocal here. This is our derivative. So go ahead now, pause the video, and try these 2 U-tries on your own. And here we go. So here, the derivative of your first term is 15x squared. Then minus the derivative here of the next term is 2/3 x. Then plus 2. Now, because again, the derivative of a constant is 0. Now to show though how you get that, so just in case, remember if you need to rewrite it. So that is a -1/3 x squared. So when you multiply -1/3 times 2x, that's the derivative, right, of x squared, 2x. 1/3 times 2 is -2/3. So that's how you get your derivative here. Then for 2b, your derivative of this function is 2x, constant is 0, then plus 12 over x to the 7th is what you should have gotten here. Now, again, to show for those who are going, wait, hold on, how did you get this value here, a positive and x to the 7th? So here we go, rewrite it, right? That is -2 times x to the -6, because x is, again, x to the 6th is in your denominator. So that means now when you find the derivative here, you've got -2 times the derivative, which is -6x to the -7 now from subtracting 1 from your exponent. So now notice when you multiply -2 times -6, there's your +12 and x to the -7 or over x to the 7. So this is the derivative of your function.